Dear students, in this session, we will discuss the most celebrated production function used for empirical analysis, namely the Cobb Douglas production function. Introduced in 1928 by Douglas, the economist, and Cobb, the mathematician. Douglas, the economist, Cobb, the mathematician. Now, this production function has been introduced from the observation of Douglas after analyzing vast amounts of US data. Its genesis, the genesis of Cobb Douglas production function, owes its origin to certain characteristics of vast amounts of data, especially from US, analyzed by Douglas, the economist. Specifically, he observed that W by Y is a constant. W is the share of wage in national income. Y is national income. So, the share of wage in national income is a constant. Or W can also be written as wage rate into L by Y. Wage rate into number of laborers employed, total wage bill, WL by Y is a constant. So that A is equal to, so that W is equal to A into L by Y, Y by E. That is, wage rate is a constant proportion of output per head. Y by L is output per head, A is a constant. So, wage bill is a constant proportion of national income or a constant proportion of output per head. Now, according to the marginal productivity theory, dou Y by dou L is equal to W. Dou Y by dou L is the marginal product of labor. W is equal to dou Y by dou L, or dou Y by dou L is, that is the MBL is equal to wage rate. And as W is equal to A into Y by L, it follows that dou Y by dou L is equal to A into Y by L. Dou Y by dou L is equal to A into Y by L. Now, these are the characteristics observed by Douglas, the economist, after analyzing a large number of US data. Douglas consulted with Cobb to suggest a production function satisfying these characteristics. And Douglas suggested that a production function of the form Q is equal to A k raised to alpha L raised to beta, where A is greater than 0, alpha and beta between 0 and 1 satisfy this condition. And this is the celebrated Cobb Douglas production function. Q is output, A is known as the efficiency parameter, a parameter representing what is known as productivity. K and L are the inputs, alpha and beta are the parameters, where alpha measures the percentage change in quantity resulting from a given percentage change in capital holding labor constant, and beta is percentage change in output resulting from a given percentage change in labor keeping capital constant. Stated differently, alpha is the elasticity of output with respect to capital, beta is the elasticity of output with respect to labor. Now, a strict Cobb Douglas production function in which alpha plus beta is equal to 1 exhibits constant returns to scale. A strict Cobb Douglas production function in which alpha plus beta is equal to 1 exhibits constant returns to scale. A generalized Cobb Douglas production function in which alpha plus beta not equal to 1 exhibits increasing returns to scale if alpha plus beta is greater than 1 and diminishing returns to scale if alpha plus beta is less than 1. So, Cobb Douglas production function exhibits constant returns to scale, increasing returns to scale, and also diminishing returns to scale. All these are possibilities. If alpha plus beta is equal to 1, constant returns to scale, greater than 1, increasing returns to scale, less than 1, diminishing returns to scale. Now, if you differentiate this with respect to L, dou Q by dou L is equal to beta A k raised to alpha L raised to beta minus 1. This can be written as beta A k raised to alpha L raised to beta is Q by L. And this dou Y by dou L is nothing but dou Q by dou L. Instead of here, beta here, Y by L is Q by L. That is, MBL is a constant proportion of output per head. So, this characteristics observed by Douglas is satisfied if the production function is Q is equal to A k raised to alpha L raised to beta. Now, let us see what are the properties of Cobb Douglas production function. Now, the form of the production function is Q is equal to A k raised to alpha L raised to beta. In log form, we can write it as log Q is equal to log A plus alpha log K plus beta log L. As we will see later, we use Cobb Douglas production function in log linear form to estimate the parameters alpha and beta. So, if you have data on quantity, capital and labor, then you can easily convert it into log terms. You will get alpha and beta, and alpha and beta are the elasticities of output with respect to capital and with respect to labor respectively. Now, a second property is the Cobb Douglas production function yields diminishing returns to each input. Diminishing returns. That is, given this production function, dou Q by Say, as an example, dou k is equal to a alpha k raised to alpha minus 1 L raised to beta. A alpha k raised to alpha minus 1 L raised to beta. That is, if we take a k here, q here, now this is the function showing q as a function of k. We can take it as q as a function of L also. Anyway, dou q by dou k is the slope of the projection function. As we are differentiating with respect to k, L is held constant. This is short run projection function. If you differentiate it again, dou square q by dou k square is equal to alpha into alpha minus 1 a k raised to alpha minus 2 L raised to beta. As you can see, this is the slope of q is a function of a k raised to dou q by dou k is the slope of the total product here. Dou square q by dou k square is the slope of the marginal product. And as you can see, as alpha is less than 1, alpha minus 1 is negative. So the entire expression is negative. Alpha minus 1 is positive. Sorry, minus 1 is negative, but it is 1 by k is positive. So if I draw the MBL is like this. Sorry, MBK is like this because I have taken k here. That is, this expression shows the slope of MBK and the slope of MBK is negative. So the second property is the function yields diminishing returns to both inputs. The same is true if you differentiate q with respect to L rather than k. That is the second property. Now, a third property is a strict Cobb Douglas projection function in which alpha plus beta is equal to 1 exhibits constant returns to scale. Now, you consider this projection function and suppose that we multiply k and L with a constant k. I mean constant m. Then f of KL f of mk ml is equal to a m k raised to alpha m L raised to beta. This becomes m raised to alpha plus beta a k raised to alpha L raised to beta. So the first point is that the projection function is homogeneous of degree alpha plus beta. And if alpha plus beta is equal to 1, it becomes m into a k raised to alpha L raised to beta. Homogeneous of degree 1, and if alpha plus beta is equal to 1, as we have discussed in the previous class, the projection function exhibits constant returns to scale. It is linearly homogeneous. Remember this. In the Cobb Douglas projection function, it is not necessary that alpha plus beta is always equal to 1. In the context of the US economy, while discussing the returns to scale phenomena, we have seen that in the aggregate, alpha plus beta is equal to 1. But when you study the projection function of a particular sector, that particular sector may exhibit constant returns to scale, increasing returns to scale, diminishing returns to scale, anything is possible. And if alpha plus beta is always equal to 1, then there is only one returns to scale, that is not correct. Now, it is homogeneous of degree alpha plus beta. If it is alpha plus beta is equal to 1, it exhibits constant returns to scale. Otherwise, if alpha plus beta is greater than 1, it exhibits increasing returns to scale. Alpha plus beta is less than 1, diminishing returns to scale. And when alpha plus beta is equal to 1, we say that the Cobb Douglas production function is strict. Otherwise, it is known as generalized. And when alpha plus beta is equal to 1, then it follows that as alpha plus beta is equal to 1, then we can write it as 1 minus alpha is equal to beta, or 1 minus beta is equal to alpha. We can write alpha plus beta is equal to 1 means beta is equal to 1 minus alpha, or alpha is equal to 1 minus beta. Now using this, we write the production function as a k raised to alpha L raised to 1 minus alpha. Actually, the coefficient of L is beta, as alpha plus beta is equal to 1. In the strict Cobb Douglas case, we write it as a k raised to alpha L raised to 1 minus alpha. Now, we consider 4 properties specific to strict Cobb Douglas production function. Specific to strict Cobb Douglas production function. The first one is a strict Cobb Douglas production function in which alpha plus beta is equal to 1. Both the average product of capital and average product of labor are functions of K by L alone. This we have considered in a previous class in the form of properties of linearly homogeneous production function, the general case. Now we consider the same in the context of Cobb Douglas. Now, as Q is equal to a k raised to alpha L raised to 1 minus alpha, we can write Q as equal to a k raised to alpha L by L raised to alpha. This is L into L raised to minus alpha divided by L raised to alpha is equal to A. I write K by L as Q, then it becomes Q raised to alpha into L. A, where Q is equal to K by L. Q raised to alpha then is equal to K raised to alpha by L raised to alpha into L. So, A Q raised to alpha into L. Then what is average product of labor? That is Q by L is equal to A Q raised to alpha. Division by L give you A Q raised to alpha. So, APL is a function of K by L alone, as it is clear from the equation. What is APK? APK is equal to Q by K is equal to A Q by APK is equal to Q by K. So, A Q raised to alpha L by K, because this is Q. A Q raised to alpha L by K is equal to A Q raised to alpha by L by K become Q by L, Q. So, is equal to A Q raised to alpha minus 1. A Q raised to alpha minus 1. So, APK is also a function of K by L alone, because A, alpha, etc. are constants. So, both the average products APL and APK are functions of K by L alone. And remember this, this property is satisfied only in the case of strict Cobb Douglas production function. Both average products are functions of K by L alone. And as we have suggested earlier, we can also show that both the marginal products are also functions of K by L alone. Let us see. Both marginal products MBL and MBK are functions of K by L alone. So, dou Q by dou K is equal to alpha A K raised to alpha minus 1 L raised to 1 minus alpha is equal to alpha A K by L raised to alpha minus 1. Sorry. Q is A K raised to alpha minus 1 L raised to 1 minus alpha can be written as alpha A K raised to alpha minus 1 L raised to minus of 1 minus alpha. Minus of 1 minus alpha. So this is equal to alpha A, then K by L Q raised to alpha minus 1. Alpha A Q raised to alpha minus 1. So marginal product of capital is a function of K by L alone. Similarly, dou Q by dou L is equal to dou Q by dou L is equal to 1 minus alpha A K raised to alpha L raised to 1 minus alpha minus 1. This becomes 1 minus alpha A K raised to alpha L raised to minus alpha. And this can be written as 1 minus alpha into A Q raised to alpha. 1 minus alpha into A Q raised to alpha. So both the marginal products are functions of Q, that is K by L alone. So for a strict Cobb Douglas production function, first property is it exhibits constant returns to scale. Second property, both the average products are functions of K by L alone. Third property, both the marginal products are functions of K by L alone. The fourth is a linearly homogeneous production function satisfy Euler's theorem. Euler's theorem. That is Q is equal to dou Q by dou K into dk plus into K plus dou Q by dou L into L. Euler's theorem, also known as product exhaustion theorem. Now this can be written as K into capital letter K into, we have already derived dou Q by dou K as alpha A Q raised to alpha minus 1. Alpha A Q raised to alpha minus 1 plus L into dou Q by dou L as 1 minus alpha A Q raised to alpha. 1 minus alpha L into 1 minus alpha A Q raised to alpha. This can be written as L A Q raised to alpha into K alpha by QL plus 1 minus alpha. L A Q raised to alpha is taken out. What remains here is 1 minus alpha. If you expand this, you will get it. Expand this and you will get it. So this can be written as equal to L A Q raised to alpha into This K alpha Q by L can be written as alpha. Q is equal to K by L. Then L and L, K and K cancels, plus 1 minus alpha is equal to alpha plus 1 minus alpha is alpha plus 1 minus alpha is by assumption 1. Alpha plus 1 minus alpha is 1. So this will give you L A Q raised to alpha. That is Q. L A Q raised to alpha. This is another expression for Q. So K into dou Q by dou K plus L into dou Q by dou L is equal to Q. So the strict Cobb Douglas potential function satisfies Euler's theorem. The remaining properties will be discussed in the next class.